Okay, so we are going to start exercise 5.1. So before we start, continuity, what it was. Continuous function is nothing but in which the graph of the function does not break. If the graph does not break, that is continuous. Okay, so this concept we will use and will solve the problem. And through limit, how is to show that? Limit, left hand limit, you can simply write x tends to c. If you want to show it in a particular point, then take c minus, this is your left hand limit, your fx will tends to something. What is that something? F of c. Okay, if you take x equal to c, your y value will be what? fc, right? So as your x will be c, x tends to c from left side as well as from right side. Okay, your fx also will tends to what? Fx will tends to f of c from left as well as right. Okay, so left hand limit must be equal to right hand limit, and it must be equal to how much? fc. Left hand limit and right hand limit both must tends to this one and exactly this one. Okay, and I have explained you this one in the previous video. Okay, so this question we will solve here. I will show you the graph also as well as how to solve like this with the help of limit. So see, first question, what it says: prove that the function fx equal to 5x minus 3 is continuous. So this function I have to show it is continuous. Continuous means its graph should not break. So I can easily draw the graph of this one, right? Now see, in question they didn't ask you for whole function. They have just asked you prove that the function this one is continuous at x equal to 0 only. So at x equal to 0 you will have fx something, right? What will be fx? 0 if you put here in place of this, you will get minus 3, right? So see carefully. What I'm trying to explain here is, let me show you the graph. So you can see the graph here. I've already plotted 5x plus 3 when I minus 3. When I click this one, you can see this is the graph. Okay, this is the graph. You will see on both ends it will never end. Okay, it will just go on, and you can see this graph is not breaking at any point. Okay, so graph does not break, right? Now what we have to check here is, so first thing we know this function is continuous. From the graph you can see it is not breaking anywhere. Okay, if you keep on moving like this, it will just go on till infinite. Okay, so it's not breaking at any point means what? This function is continuous, obviously. Now they didn't ask you to find out this whole graph. They have just asked you at particular point, right? What is that point? X equal to 0. So you can see x, where it will be 0 here, x value this one 0, right? You can see this is the 0, right? Then what you will get? Y how much? If I put minus 3, you can see x 0, what will be your y? This is your 1. Okay, this will be minus 3. I have taken 1 unit as to be 10. Okay, so that's why you may not be able to understand that this is, you might seems it is at the half portion, right? But this is not half portion. I have taken the unit to be 10. Okay, 10 unit I have taken. So that's why. Let me change this one. Okay, so I have changed the unit. So see, you can see as your x is 0, y is how much? Minus 3. Now at this point I have to check whether the function is continuous. So you obviously see, you can see at fx equal to minus 3, this function, this graph is not breaking. Can you see? So obviously this is continuous, right? So how I will show you in the writing portion through limit, how to show. So see, your given function is fx equal to 5x minus 3, and how to show limit is function is continuous. Left hand limit is equal to right hand limit is equal to f of particular, f that particular point, whatever you're taking, that f of that value you have to find out. Okay, so see here, given function is this one. Now I already know from the graph that it is continuous, right? So how I will write in terms of limit. So first thing what I will do, I have to check the function is continuous or not at x equal to 0. Given function is this, at x equal to 0 I will check whether the function is continuous or not. So how I will check? So graph, you got something like this, right? At x equal to 0, fx is this one. At this point I have to check whether it is continuous or not. So to check that one without graph, how I will do? So see, I'm in graph, I'm just explaining. I will explain it like this. I will just show that these points which are there, it is approaching towards this point. Approaching means what? I'm drawing this line. And if I can approach from this side also, and if I can touch this point from this side as well as from this side, then can I say or not that this is continuous? Because I have already shown that this is not breaking at this point, right? So what I have to show is left hand limit. Your left hand limit will be which one? This will be your left. From left you will move like this, right? So this will be your left hand limit, and this will be your right hand limit. What does that mean? See, limit, how we used to write down limit. I know some of you have confusion in this one. Left hand limit we used to write like this, fx. Meaning is what? As your x tends to c from left, your fx will tends to some value. Whatever comes out here, fx will tends to that one. So this one, how I will explain here. As your x tends to 0 from left, your fx must tends to this point. Okay. So see, I will find out left hand limit. So basically, without understanding, why I said that without understanding also some student can do with, if you remember this one, left hand limit, right hand limit is equal to, at that particular point, whatever is the function that you find out, it must be equal, all must be equal. So left hand limit I am finding. So left hand limit will be how much? Limit x tends to what? 0 minus, okay, f of x is equal to limit x tends to 0 minus fx is what? 5x minus 3. And we already know how to solve this one, right? This is determinant value. If I put 0 directly here, I will get determinant value. So no need to think about you are approaching from left or something. Directly you can put the value. So 0 if I put here, what you will get? Minus 3. So what I can say here is, as your x tends to 0 from left, your fx will tends to minus 3. So you can see, as your x tends to 0 means you are taking this point. If you keep on taking this point, this point, this point, this point, this point, your fx also will be like this. This point, this point, you will get fx like this. This point, this point, this point, all this point you will get. Okay, means what? It is forming a line here. Okay, and it is approaching towards this point. This is what the meaning of this portion. Now I will find out right hand limit also. Right hand limit. Limit x tends to 0 plus. I am writing this one in detail here. Okay, in the next question directly I will do fast. Fx is equal to limit x tends to 0 plus, means I am approaching now from the right. Approaching from right means I am taking these values now, x. Then what y value you will get? You will see, you will get this one. You can check that one with the tabular form also. Okay, this is what the meaning here. So fx will tends to what? Means as your x tends to 0 from the right, your fx must tends to this one. Okay, so we'll see. Limit x tends to 0 plus fx is how much? Oh, I have not written here. 5x minus 3. So directly I can write, right? So in this case also this is determinant value. So directly I can put the value here. 0 I can put it. So what you will get? Minus 3 again. So what does this mean? Again, as you move towards 0 from right, your fx will move towards minus 3. So you can see I got this points as well as this point. So it's like this. As your x tends to 0 from left, your fx will tends to what? Tends to, I'm using the word tends to, minus 3. It will come closer towards minus 3. So I'm getting this line. Okay. And this means what? As your x tends to 0 from the right, your fx is tending towards minus 3 from the right. So I'm getting this line. Now it is tending means approaching towards 3, but it's still not touching 3, right? So to find out that one, this point also must be there in the line. Then only I can join this one. Yes or no? Then only it will not break. Yes or no? So to find out this one, what I will do? Obviously at this point, exactly point, this approaching nearby point, I have find out fx value also. Here also I find out fx. Now let's see at this one whether I will get this point or not. So obviously I have already got this one. I can directly say from here. If I put 0 here, minus 3 will get. So fx I will find out. Fx at, I will write down directly f of 0 is equal to how much? Minus 3. So what I can write here? Left hand limit is equal to right hand limit is equal to f of 0. Can you see? So this means what? Simply if you write down left hand limit, right hand limit, whenever it is equal, directly I can write x tends to 0 directly I can write. Instead of writing minus plus, I can write directly 0. When I write like this, it means what? Left hand limit and right hand limit same. F of x is equal to f of 0. This is the presentation. Properly I have given first one, okay, so that you can understand. You don't have to write exactly like this in exam. This will be lengthy, okay. So limit x tends to 0, fx equal to f0. This is what the definition of continuous function there, okay. So if you understand well, you don't have to memorize that definition. Is this clear? So since this is equal to this one, therefore fx is continuous at x equal to 0. If you still have confusion, let me show you the other one also. At x equal to minus 3, I have to check now. Okay, let me take another page. At x equal to minus 3, given function is what? Fx is equal to 5x minus 3. Okay, so first I will find left hand limit. X tends to minus 3 from left. What will be your value of this one? Left hand limit will be how much? This is what left hand limit, right? As your x tends to minus 3, what your fx will tends to, I have to find out. Limit x tends to minus 3, fx is 5x minus 3. So again, if I put minus 3 here, you will get determinant value, right? So directly I can put minus 3 here, so you will get minus 15 minus 3, that is minus 18. In the graph, if I will explain this one, how I will explain? 1 2 3, this is your minus 3, right? So I'm approaching means what? I'm taking these points. Then if you take x, this one, what y value you will get? Y value you will get which is very near to minus 18. Minus 18 will be down here somewhere, right? So it will be this point, right? If I put minus 3 here, this point, okay. So when I take this near value to minus 3, fx you will get something here, very near to this one. Okay, I will show you in the graph also. This line I will get. Okay, next right hand limit I will find out. X tends to minus 3 plus fx is equal to limit. Again I repeat, simply by listening you will surely get confused. Okay, you need to analyze what I am saying here in the graph. You try to analyze yourself, think yourself, take your graph and try to understand this portion, whatever I am explaining here. If you simply listen, obviously it will be complicated for you. Okay, limit x tends to, that's why in class 11 also I said limit is a base of your calculus. So fx is 5x minus 3. So can I put minus 3 directly here? Yes, this is determinant value. So 5 into minus 3 is equal to minus 18. So from the right side also it is approaching towards. So I am getting all this. So when you take these values very close to this, why I'm taking very close to, why not here x? The reason is I have to find the function is continuous at this point only or not. Here only. If it does not break here, then my problem solved. I can say that it is continuous. I don't have to check somewhere else. Okay, they didn't ask you to check continuous for whole function. Only for this point I have to check. Means this, at this point it is breaking or not, I have to check. Okay, so I got this line also. When you take this one, it is approaching towards minus 18 means what? This. When you take x, this, your fx also it will be something here, which is very near to minus 18. Okay, now I use the term tens, right? Tens means what? It may not touch exactly this point. This point may not be here. So if you want to confirm that this point also there in the line, if this point, if you remove it from here, what happen? It will break, right? So if you want to confirm that it should not break, what will happen? This point you have to bring it back here, right? This point must be there means what? X minus 3, y minus 18 also must be here at this point. So f of minus 3 also I have to find out. Okay, how much it will be? 5 in 5x minus 3. In place of x minus 3 I will just put it minus 3. It will be how much? Minus 18. So I got this point also, right? So means what? This is continuous, it will not break. Okay, this is what the meaning here. So here what I will write, left hand limit is equal to right hand limit is equal to, if you don't write this one, no problem, you can simply write limit x tends to minus 3. This time I'm not writing minus or plus because I have seen that both are same. So whenever both are same, I can simply write minus 3. If I don't write any sign here, you understand that left hand limit and right hand limit are equal. It is equal to how much? This is also equal, right? Minus. Okay. So this is what the definition was. Limit x tends to minus 3, fx equal to f of minus 3. If it is equal, then it is continuous. Then I can say fx is continuous at x equal to minus 3. Okay, you just have to write that one. So if I show you in the graph also, you can check. This is your minus 3, right? X equal to minus 3. What will be your function here? Y value. You can see this is your minus 3 line. If I scroll this little bit, this is your minus 3, minus 3, minus 3. This point. Can you see this one? What it is? 18. So you can see at this point, it is not breaking the graph. Right? So through graph, if you have the graph, you can easily say whether the function is continuous or not. But drawing graph, it will consume time. Okay, I know that some student might be finding this one tough, but once you will understand, once you will know how to do it, this is much more easier compared to drawing graph. Okay, so at 18, how I have shown, I have taken like this. I have taken at minus 3 near point on your left. What kind of fy you will get? You see, when I take x here on the left side, this portion, whatever points are here, what kind of fx you will get? You just see here. If you come down here, this is the near point. This is 3, minus 3 line, right? This portion. So fx will be this one. Can you see this point? This point. This point will be fx value. This point will be fx value. This point, this point, this point. All this point you are getting. So when you move from the right side also, x, if you take right side of your minus 3, this points you will get fx. Can you see, as you tends towards minus 3 from the right, your fx also will tends like this. As you take x from the left, fx will tends like this. Right? So if it tends towards minus 18, now it is not confirmed, right, that this line and this line will touch or not this point, because I use the term tends. It is that limit concept will just give you that it will approach towards this point. Now to confirm that it will touch that point also must be there. This point also must be there. That's why we used to find out f of minus 3 also. Okay. So x, when you take minus 3, fx will be exactly minus 18. So minus 18 is also there in the graph. So this tends will also there, that point also will there. So it will join. So there will be no break. So that's why it is continuous. Okay. So I'm giving too much stress on explaining this portion because this is the basic of your calculus. Remember, if you don't understand this one, again whatever upcoming exercise are there again you will face problems. So I want you to understand this one properly. Don't simply memorize. Okay. Let me show you next question also exactly same. Examine the continuity of the function. So this time also they have asked you to examine the continuity, means this function is continuous or not at x equal to 3 only. Okay. At this point, at when your x is 3, where will be the function? Wherever it is, there it will be continuous or not, you have to check. Continuous means whether it will break or not. At that point only you have to check. Okay. So how I will do this? Again same. First find out left hand limit. So given function is fx equal 2x square minus 1 at x equal to 3. So when you will take x equal to 3, first I will approach towards 3 from the left and from the right, and will find out fx will tends to what, if it is tending towards same value or not, and that value also will be there or not at x equal to 3, that I will find out. Okay. So left hand limit x tends to 3 minus, okay, fx will be how much? Let's find out. limit x tends to 3 minus fx is 2x square minus 1. So this 3 can I put here directly? Yes, limit concept I told you, right? You can directly put the value till it is determinant. If it is indeterminate, then you have to use those rules, simplification, remember, identity, substitution, those methods. So directly I will put the values. So what it will be? 3 if I put here, no minus here, okay, this is not inverse, minus sign only. 2 into my 3 if I put here, what I will get? 3 square is 9 minus 1. So 18 minus 1 is 17. So left hand limit I got 17. This means what? As you approach towards 3, means 3 near value if you take all x on your left, what fx you will get? Fx you will get all those values which are very near to 7 on your left. Okay, so all those values you will get. 17, right? Near value, all those points you will get. Means it will form this line, right? Next, right hand limit I will find out. Limit x tends to 3 plus fx equal to limit. This you will know how to write down in one step also in the next question. Okay, you can do like that also. No need to write all this. You have already done this one in class 11. So try to write down this one in one step only. Okay, simply you know that this function is defined determinant value if I take 3, right? So directly do in one step. Okay, if it is indeterminate, then only we use those simplification and all. Those kind of question also will be there. So limit fx is how much? 2x square again minus 1, and x tends to 3 plus. So on from the right you are moving. Though means near to 3 you are taking the values, right? On your right. So fx will tends to what? Fx will be what? You will see it will be near to 17 only. How to find out that? This time also determinant, so directly put. So it will be obviously 17 again. So if I put 3 again here, obviously you will get 17, right? So it means what again? As you approach towards 3 from your right, your fx will tends to 17 from your right. Okay, if you don't understand like this, again remember tabular form you take. You'll take x less than 3 and find out fx. Take x greater than 3 and find out fx. You will see that this will tends, okay, towards 3, and this will tends towards 3. Then this also will tends towards 17 here. This will tends towards 17 here also. Okay, so left hand limit, right hand limit, I already got it, and it is equal to same. Means limit exists, and I can write limit x tends to directly 3 I can write now. Now the problem is at this. So I got this line. So to find out this graph will break or not exactly, this point also must be there. This 17 also must be there in this line. Then it will join like this. Okay, so this 17 also must be there. Means this point is what? Minus not minus 3 comma 17 it is, this point. So this point also must be there. This means what? When you take x3, your fx must be 17. So let's find out f of 3. When your x3, what will be your y? It must be 17. So 2 x square minus x, in place of x I will write simply 3 square minus 1. So it will be how much? 3 square is 9 into 2, 18 minus 1, 17. So you can see, since this two, left hand limit, right hand limit same, what I can write? Limit x tends to 3 directly, fx, and it is equal, right? You can see equal to what? F of 3. Okay, this was the definition. If you don't remember, definition was like this: x tends to c fx equal to fc. I have already given the definition in the previous class, you can see, and I have also explained how this definition came through graph. Okay, and also in every question I'm explaining that. So since this is equal, therefore continuous at x equal to 3.